Hey fellow Rustaceans! Finally, RealtimeSanitizer is directly usable from Rust. Only from nightly Rust so far, but you don't have to add a different library anymore. You can directly use the RealtimeSanitizer, which is built into LLVM. RealtimeSanitizer is a tool that allows you to track things that are forbidden in real-time code. So, for example, allocating memory, making calls to the sleep API or to HTTP, pull to HTTP requests, all stuff that is non-deterministic, printing in the terminal, and so on and so on. So it will warn you, and it's a really nice tool to build in your CI pipeline or to run locally, just to verify that your function really is real-time safe. It does not catch everything, but it is a great progress for real-time development. You find the whole project here, RealtimeSanitizer. It's added to LLVM already. And before I was showing you the standalone RealtimeSanitizer for Rust that I developed. This was the first tool to use it. It will still download the part of LLVM, just the small library. It will still download this library to make it usable in stable Rust. And that was the only way you could use it before. But it's still interesting if you're using stable Rust or you want to make use of the nice features here, which look a little bit simpler than when you use it directly from nightly Rust. But if you don't want to add an additional library, or you're okay with using nightly Rust, then this is now another way you can use it, which is great because it's a progress. And you will find all the sanitizers here in the Rust Unstable book. You see there's address sanitizer, leak sanitizer, thread sanitizer, and now the real-time sanitizer. If you click on it, you see some instructions, what it is doing. Mainly you have to care about this keyword here, sanitize real-time non-blocking. There you can disable it for temporary time by using those external C functions. And here's a complete example. If you want to follow the progress, here's the contribution to the Rust language, which Luca increasing here led. It was very nice. Thank you very much for developing this. It was merged into Rust Nightly on November 8, but only since mid of December it's really usable because there were still some bugs, or I don't know if they were introduced later, but since December, it's really usable. And you can also follow our Discord. If you check here in RealtimeSanitizer, we always have this link here. And there we have a Rust channel. So if you have any questions, just come here and ask. Luca and me are inside there in the group. And let's take a look and test it. So you see how it works. All right, here you have some of the example code, but let's first create a new Rust library or Rust project, whatever you want to use. So here's a new Rust project. Just what is happening when you say cargo new lib. And we can just run it now, cargo test, to see that the test is compiling and working. That is great. And that's the default test, which is just adding 2 numbers. And now if we want to use RealtimeSanitizer in here, we have to add this feature. This will activate a nightly feature. It's great that in Rust Nightly, not all the new cool Rust Nightly features are activated. You can opt into them one by one, so the whole thing is still running more stable. Now we want to activate the sanitize feature, which brings in all the sanitizers. And then what we have to do to make a function to enable basically the sanitizer is to say we want to use on this function, we want to use the real-time sanitizer and we want to run it in the non-blocking mode. That means in this function, it will be tracked if allocations or anything other that is non-deterministic in runtime is happening. Now, everything here is fine, so let's just add something which will actually be a violation. So this here will allocate a new vector, which is not allowed in the real-time context. And now hopefully the Zsanitizer will warn us about this. Now you see, if we just run cargo test again, it doesn't work because it says feature may not be used on the stable release channel. So we have to use nightly. You can do that with just saying plus nightly, which will then only for this command use the nightly toolchain. Or you can, before say, I don't know, cargo default or rust up default nightly, then you switch completely to the nightly toolchain. You can just do it how you want. So let's just do it for this command, cargo plus nightly test. And we see now it compiles and it works, but we are not getting warned yet, although we are calling this function, which should be non-blocking. And the reason for this is that we still have to activate the Zsanitizer here with an environment variable. And the reason for this is that now maybe we want to bring this code into production, right? And then the Zsanitizer should not be active. So we can leave this always inside of the code. And just when we add this environment variable here, it will actually run with the active Zsanitizer. Let's see here how we activate it. It's at the top of this page. Here we see how to activate it. Rust flags equal Zsanitizer equal, and then we need to tell it to activate the real-time Zsanitizer. Let's try this. Oops. Real-time. Okay, let's hope it works. And yes, we get an error message. And here we see intercepted call to real-time unsafe function calloc in real-time context. Great. And if we remove this now, then it should not warn. Everything works, the tests pass. Great. That's the way how to use real-time Zsanitizer and nightly Rust. Now, if you want to find out what the other features are, let's look here. There are 3 modes we can run the real-time Zsanitizer in, which is non-blocking, blocking, and caller. Blocking just means this function should definitely not be used in a real-time context, no matter what is happening inside of here. So calling a blocking function in just anywhere is fine. Yeah, so now we activated real-time Zsanitizer, but nothing is happening. But if we call this in a context which should be non-blocking, so we can make the whole test here non-blocking, then it should warn us. Yes, the test fails. And this time it doesn't fail with a direct violation, because we don't actually violate something in here, but it will tell us call to blocking function rtsan-standalone. That's this one in a real-time context. And this can be very practical, either because we directly want to show the user, hey, this function is blocking, don't use it, or because we do something inside that cannot be detected by the Zsanitizer, but which still violates the real-time guarantees. There are use cases for this. And maybe we have the allocation happening inside of here, but the output is a bit clearer, right? So instead of having this, which shows us intercepted call to unsafe function calloc, we get this output, which is just a bit clearer for the user of the library. So those options we have. And yeah, the third mode is caller. And caller just means it will use the behavior of the function you're calling it inside. And this is basically the default behavior. So all of the functions by default have the mode caller, and it's used internally, so you don't really have to use it in the end. The cool thing is you can add those even to modules. So if I create a module here, real-time functions, and add this to here, maybe I make a second one, which is, which is subtract, then both functions will be non-blocking. Yeah, this also does work. So you can make a whole module where everything inside should be non-blocking, which is nice. All right, and the last thing is this little part here. So you can add those two function definitions to here. It's not, that could be easier, but it's not easy to get stuff accepted to become a part of Rust. So for now, that's the way to do it. We have those two function definitions, which are part of LLVM. And with this, we can temporarily disable the Zsanitizer, which is very nice. So here we say rtsan disable. No, I just copy it from here. And here we say rtsan enable. And now everything we do in between of here can be, is not detected. And this is especially nice if we want to do a print line, for example. A print line is also not allowed, but maybe we just want to have this temporarily, or we do a panic, and we don't want that the panic here is then hitting the real-time sanitizer, because we actually want to read what is inside of this panic, okay? Let's try that now with the print line. Now we have to add that it's our module, real-time functions add. And we have to move this also inside of the module. Now it compiles. And now you see we can call the function and we can print hello. You can only see the output if you add no capture to the test. We see hello is printed, but we don't get a warning from the real-time sanitizer. Now, if we disable those, you see again that now it complains, intercepted call to real-time unsafe function write. Cool. Those are all the basic features. You can also verify if you remove it from here again, you can verify that this will actually be, that this is actually used in all functions then. Let's try it again. Yeah, it still works. Wonderful. But yeah, feel free to use the rtsan-standalone RS crate. If you're fine with adding the dependency here, then you can run it with rtsan enable equals 1. And it just looks a bit simpler here. Plus, you have the options. If we go to examples, scope disabler, you have a macro for doing this, so you don't need to interfere with those C functions. And you have, what else do we have? We have this no sanitize real-time macro as well to ignore the whole function. All right, that was it. Have fun with that, play around. It's very interesting to discover what Rust is actually doing underneath the functions. For example, I discovered that the mutex on Linux is fine to use if it doesn't block, if you directly get the access. But on macOS, it will allocate the first time you lock the mutex, no matter if you can directly get the lock or not. Kind of an interesting behavior that I didn't know was happening before, and you might discover more stuff like this when using the Realtime Sanitizer. All right, see you next time. Have a great day. Bye bye.